Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Madam Maisarah. Today we will discuss lecture 2 of 4 for chapter 5 function and graph. For this lecture we cover subchapter 5.2 composite function. The objective for this lecture, the student should be able to represent composite function using an arrow diagram, find composite function, find one of the function when the composite and the other function are given. Let's get started. The definition of composite function. It applies one function to the result of another. Consider two functions, fx and gx. We define f of gx equals to f gx, meaning that the output values of function g are used as the input values for the function f. In order to understand about composite function, these can be represented in arrow diagram. Let's say we taken three sets. Let's say we have set A, set B, set C. The function g is moving from set A to set B, and the function f is moving from B to set C. Let's say we have element x in A. We put x into gx, it becomes gx. Then gx, we take gx into f, then we get f gx. Finally, it is in short we can define this is f of gx is moving from set A to set C. Similarly, we define g of fx equals to g of x, meaning that the output values of function f are used as the input values for function g. This can be represented in arrow diagram. Let's say we have three sets, namely set A, set B, set C. The function f is moving from set A to B, and function g is moving from B to set C. Let's say we have x in here. We put x into f, then it becomes fx. And then fx is substitute into g, then we get g fx. So finally, g of fx or g composite fx is moving from set A to set C. Note that f of g does not equal to fx multiply gx. G of f does not equal to gx multiply fx. Look at example 1. The function f and g are defined by fx equal 3x squared plus 1 and gx equal 5x minus 7. The question asks to find question A, f gx, question B, f fx, question C, g f1, question D, g fx. Let's take a look at solution of example 1. We have fx equals to 3x squared plus 1 and gx equals to 5x minus 7. The question A asks to find f gx. This means that the output values of function g are used as the input values for the function f. Means that we substitute gx into f. And actually we substitute 5x minus 7 into f. We get f 5x minus 7. And then we substitute 5x minus 7 into function f. We get 3 multiply 5x minus 7 square plus 1. And then we simplify, we expand 5x minus 7, and then we get 75x squared minus 210x plus 148. Now, for question B, we have f(x). It means that the output values of the function f are used as the input values for the function f. It means that fx put into x on fx, then it will get f 3x squared plus 1. And then we put 3x squared plus 1 into x on fx. It means that 3 multiply 3x squared plus 1 square plus 1. And then we expand and we simplify until we get 27x power 4 plus 18x squared plus 4. For question C, the question asks to find GF1. So before we evaluate GF1, so we need to find GFX. It means that the output values of the function f are used as the input value for the function g. So then GFX, it means that we substitute fx into x on gx. It will get g 3x squared plus 1. So then we substitute 3x squared plus 1 into x on gx. We get 5 multiply 3x squared plus 1 minus 7. Then we expand 5 multiply 3x squared plus 1 minus 7. Then we get 15x squared minus 2. So this is GFX. And then to evaluate GF1, we substitute 1 into 15x squared minus 2. So then we get 15 multiplied by 1 minus 2. Then finally, we calculate, we get 13. GF1 is 13. For question D, the question asks to find GGFX. From question C, we find GFX. So we get 15x squared minus 2. So then GGFX, we can conclude that this is GGFX. It means that G 15x squared minus 2. So then we substitute 15x squared minus 2 into x on gx. We get 5 multiply 15x squared minus 2 minus 7. And we expand until we get 75x squared minus 17. How to find a function when the composite and the other function are given? If given FOG and fx, find gx. It means that the given function is FOG. Then it also give the front function, but we want to find the back function. So then we substitute g into fx. If given FOG and gx is the back function, and we want to find fx is a front function. So this one, you want to find front function. So then we substitute u equals to gx and find fu, then find fx. Let's look at for example 2. Given that gx equals to 2x plus 1 and gfx equals to x squared plus 4x plus 5, find fx. The question give the information, the front function and the composite function of gfx. We want to find the back function. So since it's given composite function gfx and it also give the front function, but we want to find back function, so then we need to substitute f. F is a back function into gx. So the solution, we substitute f into gx, so then it will give gfx. Means that 2fx plus 1. We substitute f into gx is 2x plus 1. So then it becomes 2 multiply fx plus 1. And then we equal with g of x given x squared plus 4x plus 5 with equation number 1. So then we get 2fx plus 1 equals to x squared plus 4x plus 1. So then we solve until we get fx. So then 2fx equals to x squared plus 4x plus 4. So then we divide by 2, we get fx equals to 1 over 2 x plus 2 square. So actually x squared plus 4x plus 4 we can factorize and we get x plus 2 multiply x plus 2. It's similar to x plus 2 square. So finally our back function is 1 over 2 multiply x plus 2 square. Let's look at for example 3. The question is if gx equals to 3 plus x and fgx equals to x squared plus cx plus 10, find fx. Since the information give the composite function fgx and it also give the back function, but we want to find the front function. So then we need to substitute u equals to gx. Find fu, then find fx. So since fgx equals to x squared plus cx plus 10 given in the equation, so since gx equals to 3 plus x, so then f3 plus x equals to x squared plus cx plus 10. So now we want to substitute u equals to gx. So let's say u equals to 3 plus x. So then make x as a subject and we get x equals to u minus 3. Then in order to find fu, we substitute x equals to u minus 3 into f3 plus x equals to x squared plus cx plus 10. So then f3x, if we substitute with u minus 3, so then we get f3 plus u minus 3. It is actually fu. Since 3 minus 3 is become 0. So then if we substitute u minus 3 into x squared plus cx plus 10, so then it become u minus 3 squared plus 6 multiply u minus 3 plus 10. So this is our fu. So then we simplify u minus 3 squared plus 6 multiply u minus 3 plus 10. We expand and simplify, and then we get fu equals to u squared plus 1. So then, as a conclusion, since fu equals to u squared plus 1, so then fx equals to x squared plus 1. Let's look at example 4. Function f and g are given by fx equals to x plus 4 and gx equals to x squared respectively. Find h such that is g f x equals to x squared plus 8x plus 3. Since we want to find h is actually the front function, and we also have the information, the composite function is g f x. But we do not have g f x. But we can find g f x since we have fx equals to x plus 4 and gx equals to x squared. So for this case, we need to substitute u equals to g f x, find hu, then find hx. Since we want to find front function given the composite function. The solution for example 4. So first, we need to find g f x, which is we substitute fx into x on gx. We get x plus 4 squared. And then his g f x is hx plus 4 squared, since g f x equals to x plus 4 squared. So then it's become hx plus 4 squared. So then x x plus 4 square is equal to, since the information in the question, hgfx equals to x square plus 8x plus 3. So then hx plus 4 square equal x square plus 8x plus 3. Let's say we have u equals to gfx, which is u equals to x plus 4 square. So by taking x as a subject, we get x equals to sec u minus 4. X equals to sec u minus 4. So then we substitute x into hx plus 4 square. So it becomes hu equals to sec u minus 4 square plus 8 sec u minus 4 plus 3. And then we simplify, we get hu equals to u minus 8 sec u. We expand sec u minus 4 square, and we also expand 8 multiplied sec u minus 4. So then we get u minus 8 sec u plus 16 plus 8 sec u minus 32 plus 3. Then we simplify, we get hu equals to u minus 13. By substituting u with x, so then hx equals to x minus 13.